Korea's most famous astronomer and science communicator, shall we officially get started? A special autumn feature with an astronomer.
Let's go see the stars.
Woohoo! Oh dear. Oh, that start was terrible, but it wasn't our fault. Like, we couldn't hear the headphones, the microphone wasn't turned on, but it wasn't too bad.
It was not.
It was brilliant. Do you like singing, Hang
No,
Song?
actually, like a long time ago, I was like enjoying the singing.
Okay.
But these days, I never.
You never go to the singing rooms, the norebangs, ever?
No, or like more than 20 years.
Oh,
I guess.
Really?
Yes.
Wow.
I never went to the like a singing room.
Amazing, because
When I come back from the United States.
Oh, not one time?
Not one time. So like more than 10 years.
10 years. So why did you say yes to singing? The writer, when she told me, I was like, why are we singing? And then she was like, no, Hansong said yes as well. So I was like, okay, why did you say yes? Are you just too nice to say no?
Yeah, at the time, like I was like, it was part of the radio show. So I was like, whatever you do, well, I'll just follow. That's what I was thinking.
Okay. You now know how bad I am at singing,
You
right?
now know how bad I am.
You're
at
better
singing.
than me, though. I completely ruined a couple of parts. But that song, actually, we did it on Daily K. We used to teach Korean through
Right.
songs.
Oh,
we
really?
chose this one time.
Oh.
And I remember, 어디야 지금 뭐해? But it was the most difficult song we ever did.
Right.
Yeah. But it's because it's like, Let's Go See the Stars, the title, that we chose that track.
Right.
So it's not for no reason, guys. There is a reason why we did this. I think one of your fans, Semi-Logic, is on board saying, so cute. Matta says, what am I seeing and hearing? I've got so many questions. Has someone been taking vocal lessons? No, we apologize, especially for my singing, but we're going to be talking now. No more singing today.
No more singing.
Unless you want us to. If you really want us to, maybe we can sing at the end or something.
All right.
So you appeared on Peters on the Block, remember? What was that? Like more than 6 months ago? It feels
I think
like a
it
long
was
time ago.
June.
Oh, okay.
sometime.
So not quite 6 months, like
Right.
four-ish months. And we had Mango on the show, thanks to you.
Yeah.
Thank you for that recommendation. Everyone didn't know that weather was so interesting.
Yes.
Yeah, he's a real good comedian. Do you work together?
Yeah, I work together, but not that many about the weather though. Basically on the geology and
Okay.
The earth science and the
nice.
astronomy or something like that.
Wow, so he knows about those fields
Yeah,
as well?
he knows about the earth science and weathering specialized.
Ah, I see, with weathering and stuff like that. And he was also, I remembered, saying that he was really into food. Was it bread or pasta? Noodles.
Right.
Like he makes his own noodles,
I
right?
think he bought like a lot of noodle makers or something like that when he went to the United States. I was surprised.
Okay, yeah, I was like, that's random. But often on his social media, he's posting up making noodles.
right.
Have you tried his noodles?
No. I'm not sure I really want to, though, but right.
I don't know. He was very passionate about noodles, I remember.
Right.
So last time, I remember we talked more about space in general, and it was really good fun. But we wanted to talk about the stars, especially like autumn is a good season for stargazing. You majored in astronomy, right?
Right.
Okay, so in this special with astronomer Hangsong, Let's Go See the Stars, we planned it totally because of you. Is autumn actually the perfect time to see stars? Is that true?
Yes. Actually, like the fall, the autumn is the perfect season for stargazing. You know, how the humid and the hot can be really humid and hazy, the stars.
Yeah.
Like, and
in the summertime.
In the summertime, and usually the cloudy. And then, well, in the fall, the humidity drops and the atmosphere gets crystal clear.
Yeah.
You know, go outside and see the skies, and it's
beautiful.
It's beautiful, right?
Yeah, in Korea we have that saying, right? That chongomabi thing.
Right,
where
chongomabi.
The skies are high,
High,
right?
right.
And the horses are fat.
And then during the summertime, the nighttime is getting short, right?
Ah, that's true. There's not much darkness.
Right. Not that much darkness, and then as you getting the winter, and the fall is in the middle of on the way to the winter.
Yeah.
So the nighttime is getting longer and longer. So we have more time to enjoy the stars.
Yeah.
And do you know what's the best part of it?
What?
No mosquitoes.
Ah, that's so true. I mean, there's still one or two in our house.
Right.
My daughter got bitten this week, but you're right. In the summertime, it can be terrible.
If you see the stars, and then if you see go outside to see the stars, or like a shooting stars sometimes in the like August or something like that.
Yeah.
The mosquito bite.
They'll eat you alive, right?
Yeah, right.
Yeah, it can be really bad. I didn't think about that. And just for your reference, listeners, my uncle is here from the UK, and he was surprised how early it gets dark. Like in October, it's about 6 p.m., right? And it's getting dark in Korea. In England, this weekend, the clocks moved, so now it's getting dark early. But until that point, it's still light, like 7 p.m., something like that.
Really?
So my uncle was like, why is it so dark so quickly? So if you don't know that about Korea, we don't, because we're a bit further down. Right. We don't get
much further down.
Yeah, we don't get such long nights in the summer as the UK. And then we don't get really short nights like the UK in the winter. So then is winter better than fall for stargazing?
Right, but the problem is the temperature is really too cold.
So it's a comfort thing.
Right.
Okay.
The thing that we have to consider is the temperature and the humidity.
Yeah.
Actually, the humidity is the really enemy to stargazing.
So the drier the better.
Yeah, dry is always better, so you can see more clear stars. Or any astronomical objects.
Yeah.
And but the cold.
Is that just because it's uncomfortable for humans? I mean, in terms of looking at the stars, is colder better or
colder better? Because
really?
it will freezing out all the humidity in the air.
So if it's like minus 20, is that even the best?
Better.
Oh wow, but not better for human beings.
Not better for human
to
beings.
actually watch stars outside, right? So when you hear the word star as an astronomer, I wonder what comes to mind for you first. Because I think for regular people, if you say star, I'm thinking like football stars or, famous celebrity stars. Are you thinking stars in the sky when you hear star?
Right. To me, stars, actually my name is the Hangsung means the academical terminology, which is the star.
Rather than 별.
Rather than 별, right? So to me, stars are like home. Like it might sound like a little bit of the philosophical.
No, it sounds beautiful.
But all the elements in our bodies came from the stars. It's actually literally true. The calcium in our bones or the ions from our blood, that all came from the stars when it exploded.
Oh, wow.
Yes.
So we are made of stardust, is like true.
Right. So the Carl Sagan said that like we all made star stuff.
Yeah.
That's actually literally true.
Like everything aside from iron and calcium, everything else as
Everything.
Well? Oh, wow.
Yeah, everything. When the universe began, like from the Big Bang, at the very first time, there were only a limited number of the elements, the hydrogen, helium, and very little amount of the lithium.
But that was it.
That was it. And since then, the hydrogen make stars, very large stars, and when it exploded, inside of the stars, they will make until the carbon or oxygen or something like that. And when they exploded, and it will just use a lot of energies, and it will combine other elements.
So it created all the other elements outside of those initials.
Right.
So without stars, we would no way exist.
No, not at all.
For many reasons, right? We get our energy, of course, from the sun, so that side of things. But our literal elements wouldn't exist.
Right.
That's interesting, isn't it? And so we got lots of listener questions. We will get to them. We got lots of parts today.
Really?
So be patient. Don't worry. But I want to get to Leon's just quickly.
Yeah.
I wonder if you're interested in astrology and if you believe in like reading the stars.
Like more than 200 years ago, like about hundreds of years ago, there were no distinction between the astrology and astronomy.
Oh, really? It was the same.
And then when I teaching in college, like back in like 2010 or something like that.
Yeah.
A lot of students came to my class.
Yeah.
And actually, their major is not the science. Their major was like the arts or music or something like that.
Yeah.
They came to my class to learn the astrology.
So they misunderstood.
They misunderstood.
You don't teach any astrology.
I don't teach astrology.
So what do you think about it, though? Because like you said, there used to be one.
Right.
But then they've split, like one is a science and one is more superstition, that kind of thing. Are they completely not compatible, do you think? Or
I think the astronomy is the study, the research area of the statistical things, right?
Yeah.
So we have to see something like in the long time, and then something happens. They just write it down on the very old notes or something like that, and it happens like it was coincidences. Sometimes it happens, but they try to make a relation. To give the meaning somehow. But right now, there was no relation actually.
We can see,
You know the solar eclipse? Have you ever seen the solar eclipse?
Yeah, I remember in the UK one time we were told not to look directly. So with a cardboard box, put a little hole.
Right.
It was, I don't know what year, but it was before 2008.
It seems like you saw the partial solar eclipse. But if you see the total solar eclipse, it will get completely dark.
Just like nighttime.
Just like a nighttime.
Wow.
And you feel the chill.
Oh, it gets cold
Suddenly gets cold.
Wow.
So it feels like a very long time. They don't even know. They don't even know what happened.
Sure.
And it feels like it will scare the people.
Sure.
Right?
Suddenly in the middle of the day.
Right. Suddenly in the middle of the day. And that's how combined astrology and astronomy get to combine each other.
How they could get mixed up quite easily. Thank you for your question, Leon. And, in the West, a lot of people, they don't believe it that strongly, but star signs are a big deal, like Leo and things like this. I'm a Leo because I'm a summer baby.
I'm a Leo too.
So we're the best. But we still look at it. It's still in the newspapers and things like that. And in Korean, like fortune telling, if you guys don't know, like those books that talk about when you were born, right? What do we call that? Saju. That's based on like astrology. Yeah. Not completely.
Not completely. Not the astrology. They based on the times, years, and then when you were born. And they matches like I don't know exactly, but they match it somehow.
Books, right? With something.
With something, and they're written in the Chinese language, right? Hanza.
Yeah, and some people believe that. Not strongly, but again, like kind of take it on board.
But I think that's the part of the like a statistically
all that data.
True, all the data. Because from a very long time, like more than 2,000 years ago, and they've been using it, and a lot of data has been gathered. So somehow they might be related to the science.
It could be.
In terms of the statistically, but not exactly.
Yeah, not 100% the scientific method, right? So, we've talked about the fortune-telling aspect, but people also, they link maybe stories and dreams to stars. Like in Western culture, we say wish upon a star, especially like a shooting star.
Right.
I think in Korea, I've seen more you're wishing on the moon for things like Chuseok and stuff like that, right? But from a scientific point of view, taking all that out, what exactly is a star? I mean, how can you define a star?
So, how can you define a star? The star is very important. Actually, the distinction between the stars and the planets and the shooting star is totally different.
Okay.
So, in Korean, star is 항성.
Yeah.
And the planet is 행성. It's kind of similar.
It's very close.
Yeah, very close and very similar. So a lot of people are getting confused between those two.
Yeah.
But in English, they're totally different, different words and different pronunciations.
Of
so
course.
they know exactly what it is. But the star is making energy by itself. basically, I can say the star is a ball of gas, hydrogen gas is burning it, and to produce the energy with the form of the light and the heat.
Okay, so those are the components of a
Right,
star.
those are components. So with the four, in easier way, it's much more complicated, but
Surely.
in easier way, four hydrogen combined inside of the star and make it helium. During that process, they will make an energy in terms of the heat and the light.
And that's why we have the sun and light coming from stars. But you can get confused, especially when you're looking at the night sky. You know, we are told, oh, that's a planet. Yeah. But it kind of looks the same.
It's the same. So actually, when you see the stars up in the night sky, and if you see something, you can call it as a 별.
In Korean, that's okay.
In Korean, even though you see the Korean dictionary, it says like everything up in the night sky shining is the star.
Oh, is a 별.
별.
Even like satellites?
A satellite
Oh,
or
really? You can call
행성.
that all 별?
Yeah.
Oh,
in
wow.
terms of the Korean dictionary.
Oh, that's interesting.
Yeah, but in scientificology, in the scientific way, we have to distinct between the planets, and stars, and satellites, and everything.
Yeah. So then a shooting star, what we call a shooting star in English, that's what 별똥별
Yeah, 별똥별.
in Korean. Is that totally not a star then?
No, not a star.
Oh, really?
But it's so bright. Sometimes it's so bright.
Yeah.
And the shooting star actually happens every day, but sometimes at a very special period, like in August or the December. Sometimes we pass the Earth, past the remnants of the way that the comet passed away. So we actually passed through a lot of dust area.
That's when there's lots in the sky.
Right, that's what happens a lot of the sky. But you know, every day, about 50 tons to 100 tons of the how can I say?
Space like debris? Or?
Space debris or something like that. Like a small debris came to the Earth.
Every day?
Every day, 50 tons to the 100 tons.
So if you're looking carefully enough, you can always see it? Every day?
Every day, but they are really small, so it's really hard to see.
Okay.
But when I up to the Hawaii, which is a very good place, at the top of the summit of the Mauna Kea, I went to outside and then I see a lot of shooting stars.
Just with your eyes, no telescopes?
No
nothing.
telescope.
Really?
Yeah.
Every day?
And to see the shooting stars, the bare eye is the best instrument to see it. You cannot see it through the telescope.
Because that's just such a small
area to see it.
Wow. So if you go somewhere with not much light pollution in the right part of the planet, you can see a lot of shooting stars.
Right.
I've rarely ever seen a shooting star. Like, I'm terrible. Like, I just look for a little while and then I'll lose my patience.
Right.
But I really want to see a clear one. I'm sure that would seem magical as well, wouldn't it? Yeah. We're going to listen to a song. So much more to talk about. We'll get to your questions as well. We're not going to sing this one, I promise. This is from 도경수. It's 별 떨어진다. Literally means a star is falling. The English title, though, I do. We're back for part 2 of our autumn special. Let's go see the stars with Hang Song in the studio talking about science in such a fun way. If all science teachers were like you, we would have more scientists.
Really?
I don't know about Korea, but England has a real shortage of people studying science at university. Like, it's quite a crisis. No one wants to study science because it's hard. In Korea, I think there's more people wanting to do science, like more people want to be doctors here and go to like medical school than England.
Right.
I think it's because of boring science teachers in England. They're just, sometimes they put you to sleep. Yeah, it's so hard. How would you encourage people to get into science?
Actually, the science is not that cold or not that hard. If you you without any science, you cannot even use your cell phones or like word broadcasting.
Yep.
It's all of the combine of the science technologies and everything. So if you are interested in whatever you use in your daily life, making it interest in your daily life and question something and then try to find out something from the YouTube or the internet, or even AI has like a lot of answers these days. So try to make a questions in your daily life. Sometimes you feel very definite. It's very true, but it has questions. So try to make a questions like in your daily life.
Yeah, when we're young, we're so curious and we're always asking questions. But the older we get, we're just like, I don't care why. It just happens and that's it. And so when my son sometimes asks me questions these days, he's getting older, so he doesn't do it much. Sometimes I would just be like, I don't know, it just is, so don't worry about it. But I should, and sometimes I do. We search it together and then we're like, oh, that's interesting.
Right.
You know, he was into some like sea creatures recently, like the mantis shrimp and stuff like that, you know, which is the one that really punches
each other.
Little prawn,
right.
yeah. And so we looked at videos and found out about like its luminescence and things, and that was really fun.
Oh.
And so if you pursue your curiosity, don't like think it's not important.
Right.
That's fun. It might not come up in the exam, but it's really boosts your curiosity. Lots of you getting in touch with many questions. Leon's saying from Singapore, many people assume stargazing requires expensive equipment. What kind of minimal gear or preparations would you recommend for someone in Korea who wants to start exploring the sky? So is buying like a cheap telescope a good thing? Do you recommend like just looking with your eyes or going somewhere?
All right, so cheap telescope is very good these days.
Oh,
actually,
really? Oh,
like
nice.
a lot of telescope has a very good sightseeings and everything. So even though you buy something, you're good to see it. But I recommend to buy a little bit of expensive.
How is a little bit of expensive? How much are we talking?
under like close to the 100만 원.
Oh, wow. That's a little bit.
That's a little bit.
Under like, what, $800 or something like that, yeah.
Not the telescope. I recommend binoculars.
Oh, really?
Yeah, binocular is sometimes much more easy to see the planets or something like that.
It's very portable as well.
It's very portable, but it's really hard to see the like a deep space object like a nebulas or something like that.
Yeah.
But even with the expensive telescope or something like that, it's really hard to see the deep sky object because of the hazy sky or something like that.
Yeah.
But the binoculars are really good.
Wow.
Yeah.
I never thought of that. They have the same function, I suppose, as a telescope, right?
Right. So the binocular, I recommend the binoculars. You can see the Jupiter.
Oh,
and
wow.
even you can see the rings of the Saturns. And
if you get a decent pair.
Right. And then these days, the binoculars have a really good functional things, which is the preventing the 손떨방, which is the trembling. Like
binoculars can prevent that these days?
Right.
How does that? They got digital like something?
Somehow, I don't know exactly
That's
how
amazing.
What it happens, but I saw that.
Yeah.
It was amazing.
It really doesn't move too much,
No.
the frame. Wow. I do like binoculars, but you're right. Good binoculars are expensive as well, right? But don't spend too much. That's a good tip. And then Jun was saying, are there any recent discoveries or upcoming like celestial events that people should look out for this year from Korea?
There will be a like Gemini Gemini meteor shower. It's coming up on December 13, around the 13 or 14, something like that.
That's when you can see a lot of activity.
A lot of meteor showers up in the sky.
Wow.
And then actually I'm running a YouTube channel, science YouTube channel, which is called 안될 과학.
Under 과학.
Unreal Science. I usually do the live events.
Oh, nice.
Yeah, during the meteor shower, Gemini meteor shower, or Perseid meteor shower during the past August. I did that well too. And then during that time, I got a permission from the the summit of the Hawaii Observatory,
Oh.
Mauna Kea Observatory,
Yeah.
and that is the most beautiful site, and then that site is the very good site to see the stargazing
Amazing.
in the world, actually.
Yeah.
And then I borrowed their video feed, and then I do the live and keep talking, and
Oh,
we see
nice.
the meteor showers or something like that. So December 13 or 14, around that time.
You should be doing a live stream.
Yeah, I will be
Fantastic.
doing the live show, and then you can comment in.
Unreal Science. Check out that channel. Make sure you subscribe as well. Ben was saying some stars are so far away that when their lights reach Earth, they're already extinct. So I've heard that. Is that true?
Right.
So how far are we talking about stars being away from us? You know, the things that we can see in the sky. How far? They're all different, I assume.
Right. So basically, we can see the stars in our galaxy, in our Milky Way galaxy.
Are they the ones that we can see?
There's a one we can see in our bare eyes.
So anything further we cannot see with our eyes.
With our eyes, but using the telescope or
Yeah.
the James Webb Space Telescope or Hubble Space Telescope,
Yeah.
which is a very good telescope, and then they are even space telescope. So up in the sky, they don't
nice.
bothered by the atmospheric effect or something like that, and we can see much more further, but. The diameter of the Milky Way galaxy is about 100,000 light years.
100,000 light years.
Yes. That means if you see the at the very bright,
Yeah.
it should be very bright. Otherwise, it will be extinct on the way to see us. And it should be very bright. And then that means the light you seeing right now
Yeah.
is the 100,000 years before from now.
That light.
Right. If you see the up in the sky and the light shining, everything, and all the lights are coming from different time scale,
Because of the different distances.
different
right?
distances. Even though you see the a 2D,
Yeah.
but they are on the 3D.
Of course.
Right?
That's so interesting to think. All of those lights are from different times. So
Right.
it's not quite time travel, but you're seeing different times. with
You
your
see
own
them
eyes.
like the past.
That's so crazy. Isn't
Right,
It?
and the closest star from Earth is about 4 light years away, which means that if you go to that star with
Yeah.
the speed of light,
Yeah.
it will take more than 4 years.
That's insane, isn't it? And I think I learned at school that stars, when we look at them, they kind of all look the same, although some look a little bit maybe reddish. Wasn't that the North Star has that kind of tinge?
Right.
Are stars different colours then, if
Right.
you look closely? Are they different colours because of the fuel or the distance, or what makes them different colours?
Actually, different colors are their actual colors, intrinsic colors.
Oh,
So
wow.
stars do have colors, and it's all about actually the temperature. Temperature of the stars.
And is that different depending on how old the star is, or like how big it is?
Depends on how massive it is. So blue stars are usually hottest,
Yeah.
and the red colors are usually coolest one. And our sun is in the between of them. It's
Okay.
about 600,000 degree.
Wow.
Something like that at the surface. Surface temperature is about 6,000 degree. So they comes white, yellow, red, blue, or something like that. Red stars like Betelgeuse in the Orion.
Is that the name of the star?
Yeah, it's
Betelgeuse.
Betelgeuse.
Nice.
That's
Good
one of the
name.
brightest star up in the sky, but it's close about 400 light years away. But it's huge.
Yeah.
It's so huge that it will just devour all our solar system in
If it
one
got
star.
close.
Yeah.
Oh my goodness. Wow. So talking about these different colours, I don't really see it when I look up. I'm not very vigilant. But when you look at the pictures, the beautiful picture of the Milky Way, then you see different colours and
Right.
shades.
White. Most of them are white, but sometimes you can see the blue. You can see the orange or red.
That haziness in that photo of the Milky Way, where is that haziness coming from?
The haziness coming from the in the disk of the galaxy. Our Milky Way galaxy is a spiral galaxy.
Yeah.
And most of them are sitting at the very disk. It's very flat.
Oh.
It's very flat.
Wow.
It's like a UFO, something like the UFO.
Why is it flat? Because, yeah, there would surely be freedom to be up and
Right.
down and things like that.
Right.
But they're just keeping...
Some of them has an like elliptical or has a random shape, but
Yeah.
our Milky Way galaxy has a spiral,
Yeah.
like in the flat because of the day spins each other. They orbiting each other. They revolve.
Oh, wow. Around in the same kind of plane, right?
At the very center of our Milky Way galaxy, there's a huge, giant monster black hole sitting inside of the center of our galaxy.
Oh, really?
Yeah.
At the very middle.
Right. So basically, every single object in our Milky Way galaxy is rotating
Around that.
that monster black hole.
It's not like sucking things in,
No,
is it?
not at all.
Okay, so we're all right. Steve from San Francisco was saying, you were mentioning the differences between a planet and a shooting star, etc. But what makes a planet different from an asteroid? Then?
Oh.
And then Forrest Philippa Hartley, he's one of our space experts. He works
really?
in aerospace in Florida,
Whoa.
I believe. And he said, in his opinion, it's mass. So a planet is a lot larger than an asteroid. And you might have heard a bit of a ruckus, a fight a few years ago about Pluto losing its planet status. That was due to its relative low mass. Is he correct? What do you think about that?
Right. The Pluto actually lose their status as a planet.
That was sad, yes.
Right, it was sad, but they just degraded it to the dwarf planet. It is called the dwarf planet, but I want to say that it's a part of the planet.
Oh, really?
Yeah, because it's round.
Ah,
Right?
that's another definition of a planet.
That's a spherical shape. So the planet has to be making around the sun, make an orbit around the sun, and asteroids has a random shape usually. Right?
So they can be any shape.
Yeah, it can be any shape. It's not close to the round, but it's not like a very smooth spherical.
So all planets are pretty smooth.
Pretty smooth because they have enough mass when they were formed, and they have enough time to revolving itself, and then make an orbit around. So when we called it, that's probably has a planet, but planet and the moons are different. Moons are the spherical shape as well.
Yeah.
Right.
So why is that not a planet?
But that's not a. We call it as a satellite.
Yeah.
As a moon, because it orbits the planets.
Okay, so it's not the shape for that; it's what it's orbiting.
What
as
it's
well.
orbiting.
Wow. I'm getting so much knowledge, and yeah, it is like going straight out. So I'm not going to remember this tomorrow, but it's so fun and entertaining to learn like this.
Right.
We'll get to some more music, some more of your questions. We've got lots to get through in our script as well. We won't get through half of it, I'm sure. Don't worry. 10 centimeters up next with 별자리, which is talking about like a constellation star. Why do all songs to do with stars have that kind of guitar and this feel? Why can't stargazing be like rock music or hip hop or something like that?
It's night.
It's nighttime. It's kind of calm.
Yeah, it's kind of calm, and you can. You don't want to wake up like other sleeping people.
That's true. That's why it's romantic as well.
Right.
We've got lots of questions and comments coming in. Thank you for getting in touch. We will do a few more on the script because we just played the song 별자리, which is like constellation, right? So I remember when I was a Boy Scout as well, didn't they say like find the brightest star, that's the North Star, and then you can't get lost, like that will give you your bearings. Is that true? Like, is that a thing?
The North Star is not the brightest one.
Okay.
Well, do you know how to find out the Big Dipper?
The Big Dipper, the one that looks like a saucepan kind of thing. Yeah, okay.
So, and if you find up the Big Dipper, and then like a Big Dipper has like a 4, which has like a
Make the
saucepan.
bowl,
Make a bowl, and last 2 stars close to make it the extension line. Yeah, and you can see the North Star.
Oh, so if you're kind of looking at it, and this is the right hand side. Those 2 you just keep following.
Right.
and that's
That's
the North Star.
North Star.
And then if you follow that, that's vaguely north. Is it?
that's almost the north. That does not move.
Okay,
at
that's
all.
always in the same point, and then the rest are rotating.
Mm-hmm.
Oh, so that's why it works. I was wondering, I was always like, how does that work when the stars are always changing position? So does that
Right.
mean, like here in Korea, are there certain constellations that are more visible than other parts of the world?
No, actually, no. And
No.
based on the latitude, we have work good time, but you cannot see the like a southern sky or something like
Ever.
that ever.
Yeah.
So the best place to see the lot of stars are if you sitting in the equator near the equator part.
Then you can see mostly everything.
Mostly everything.
Ah, wow.
Right.
But if you are like at the very north or the very south, does that not mean you could see other constellations as well?
Right. So like which is called the 남십자성, I don't know, Southern Cross or something like that. You cannot see in the northern hemisphere. But if you go to the Australia or other southern hemisphere countries, you can see the like a Southern Crosses. It's more like a Big Dipper, like in the northern hemisphere.
So can they not see the Big Dipper
No.
from down there? So as an astronomer, is that interesting then to go to the southern hemisphere to see a
Definitely.
different sky?
A different sky. Even the face of the moon is flip away.
Oh, that's so intriguing as well from an astronomer's point of view.
So first quarter is we see the like the right side of the brightening in the northern hemisphere. If you go to the southern, the left side is the shining at the first.
Because you're kind of upside down.
Yeah, upside down.
Oh, wow. I never considered that. That's so interesting. I'm assuming, like with most things, though, majority of astronomers are in the northern hemisphere. Is that true?
Right.
So like, there's
Actually, a lot of people, most of the continent are sitting in the northern hemisphere. So many people are living in the northern hemisphere.
so there's more maybe bias towards northern hemisphere stuff.
Like right-handed or left-handed, something like that.
We just kind of forget about it. We've also got Semi-Logic saying, did you see the Lemon Comet?
Oh.
What is the Lemon Comet? Why is it called a Lemon Comet?
These days, a lot of comets are visible these days.
Oh, really?
And
Just randomly?
Yeah,
like
randomly.
no particular reason?
Right. And then those comets are like orbiting period is very long. So it's one time see comets in your life.
Oh, you'll never see them again?
no.
Okay.
And the lemon comet is if you type on the Google or something like that, like you can see the lemon comet. It's very bright.
Does it look like a lemon? Is that why
it's a
called
lemon.
Oh, really?
It's big because it was the visible. It was found by the lemon mountain lemon survey.
Oh, okay.
That's why they name
it lemon.
follow the name of the lemon.
Ah, it's with two M's, I see. Comet Lemon.
Yeah, lemon.
Ah, interesting. It
And
does look amazing.
not the real
Not the fruit.
fruit lemon.
I thought it was the fruit. And I was like, okay, kind of looks
It's a
like
lemon
a lemon.
mountain in the United States.
Wow. So that one was visible recently, was it?
Yeah, right.
And then never again.
Never again.
Aw.
That's very beautiful. That's perfect time these days, and it's gonna be very bright. It's gonna be closest to us, close to the November 10th or something like that.
Oh,
so
wow.
these days are the brightest. These days are a good time to observe the lemon
So
comet.
when we think of comet, we think of it going whoosh past us, but you're not actually seeing it move.
No,
in the sky.
it's more like staying during the night.
Yeah.
But like a moon, the rising time is getting different, and then like a little position of the sky is getting changed. But until during the night time, it will just stay there.
Yeah.
It's not moving.
Oh, that's so intriguing as well. And when I've listened to physics, because physics gets really hard suddenly in school from my memory.
Right.
Like,
But your major was like biology as well.
yeah, but that was so much easier than physics. Like, I don't get offended, any biologists, but I think biology is by far the easiest. They're like chemistry and physics with all the math elements in there and like formulas. It was another level. Maybe because I'm weak at maths. I don't
I
know.
feel the biology is the hardest one.
I did hear that from physics majors, actually, because I guess maybe different specialities, right? Biology is not it doesn't overlap much with physics, in my opinion. So much respect to you. But when I was interested in that really hard physics, it was when they were talking about like stars dying and being born.
Right.
Like that just sounds interesting. So how does that happen? Like a star being born from what? From nothing? Like there was no star and then suddenly there's a star? How does that happen?
So stars are born in the very giant gas cloud. We can see the like a nebula. Sometimes we can see the nebula, and then I don't know if you have ever seen the James Webb Space Telescope images, and then they sometimes release the very beautiful image which is called the nebula.
Okay. Images from the telescope.
Yeah. And then those images, those are where the star is born, because it means they will reflect a lot of dust to reflect the lights from the stars. And then dust is actually the ingredients of the stars.
Oh, to make a star, you need the dust.
So there are some bump of the dust, and then it will just try to collect more dust and more dust because of there's more gravity over there.
Are we talking about tiny dust particles?
Yeah, the tiny dust particles. And then when it forms and gets more and more and bigger, and then it will just suddenly it gets dense, and it will ignite the hydrogen fusion that I mentioned before. So 4 hydrogen make an helium, and then that's the stars. That's the baby star was born.
How big are we talking?
How
like
big?
for that to start, like how much dust do you need to have? Like a tennis ball, or the size of a moon, or
no, size of the at least the size of the at least the size of the Jupiter.
Oh wow, okay, so we're talking
So it's
massive.
a lot
of dust coming together, and then that starts the reaction, and that's the birth of the star.
Right, and the death of the star.
Yeah, conversely, how does that happen?
Death of the star depends on their mass of the star. Our sun will just die as a white dwarf.
Okay.
It won't explode.
Oh, that sounds good for us.
Yeah,
if
that
it
sounds
doesn't
good.
Explode.
But before they go to the white dwarf, it will just expanding and expanding.
Oh, that doesn't sound good.
Yeah, that will devour our Venus and the Earth.
It will come to us.
Yeah, it will come to us.
Oh goodness! But that's a long time away.
It's so long time away.
We've got time.
Right.
And so that expands, and then a white dwarf is what? It just runs out?
Yeah, it just runs out, and then it will get shrunk. And then if the mass is greater than the sun, like 7 times or 8 times, it will explode.
Oh, wow.
It will explode, and then when the sun goes to, when the star goes to the explosion, it will call the supernova. And then there is a neutron star as remnants, as a seed or something like that.
And that is bad for everything close by if it's a supernova.
And it's more mass that will die as a black hole.
Oh, wow. And that does not sound good. So interesting, Hang Song. Thank you so much for coming back on the show, especially in this perfect season, like you said, for seeing the stars. No mosquitoes, but not too cold. So if you're in Korea, get out and look up into the sky, right, at night time. You're welcome here anytime you like, Hang Song, of course. Thank you so much. And would you like to say a final message to our listeners?
Thank you so much, and I'm really enjoying the stars and the universes every time here in talking with Peter. So yeah, invite me anytime. I'll be
don't say
available.
that. Our writer will invite you straight after you leave the room today, and make sure you subscribe to Unreal Science as well. Hang Song, thank you so much. And this song to take us both out. I'll be back tomorrow at 9 a.m. Channabi with 가을밤에 든 생각, a thought on an autumn night. It's been your daily dose of Korea. #DailyK out. Bye-bye.
Bye.